Ahead and start this.
Bless you.
Okay. Was that like 14 sneezes I just heard? Okay. All right. So I've got the review assignment for the next exam ready to go. So here's what it is. Let me blow this up just a little bit. It's page 434, 1 through 81, just the odds. So that's about 41 problems. Okay. Some of them are really quick, and we're going to shorten it just a little bit. So this means skip every third odd. And then it says memorize the formulas and the identities on the study sheet. So I just handed you the study sheet. We'll take a look at that in just a second. Okay? But these are the problems that I want you to do. So 1 through 81, just the odds, but skip every third odd. So that means you're going to do 1 and 3, skip 5, then you're going to do 7 and 9, skip 11, and so forth. Everybody clear on that? Okay, that cuts it down to about a third of those 81 problems there. Okay, and again, some of them are really quick. Some of them say things like this: draw an angle of 4. So literally that fast. Okay, 4 radians or 4 degrees? 4 radians. This would be 0. This is 1.57, or pi halves. This is pi, so 3.14, and this is 4.71. So again, we got pi halves here, we got pi here, and we got 3 pi halves here. And all the way around would be 6.28, or that would be 2 pi. So 4 would be about right there in the third quadrant. I mean, seriously, you have some problems that are literally just like that. Okay, so they go, some of them go very, very quickly. Okay, some have multiple parts. Okay, but that should be a pretty good review assignment. And then let's take a look at this study sheet right here. I would not ask you to do this entire sheet on the test. Okay, but I can tell you there are going to be problems on the test that look exactly like this. Okay, so for instance, these two right here, I can almost guarantee you those exact problems with the same wording and everything, give or take, are going to be on the test. I wouldn't have you fill in the entire unit circle, but I might say fill in quadrant 3 or fill in quadrant 4, quadrant 2. I might tell you a quadrant that you've got to fill in. Okay? And the instructions on this are: mark all the common angles. So start with 0. Okay, there's 45, there's 90. There would be 30, and there would be 60. So mark that in degrees and radians. So this would be pi 6, pi fourths, pi thirds, pi halves, and you'd continue going around. In degrees, this would be 30 degrees, 45 degrees, 60 degrees, 90 degrees, and so forth. Go all the way around the circle like that, and mark down each one of the coordinates. So this would be 1, 0. Okay. This x-coordinate starts big and then gets small. So this x-coordinate is going to be what, Lynn? Square root of 3 over 2, comma, 1/2. The next one at 45 degrees, they're both the same. So that's radical 2 over 2, radical 2 over 2. Okay, the next one, remember how they get big and small in nice organized systematic fashion? This is going to be 1/2 for the x-coordinate and radical 3 over 2 for the y-coordinate. And then this is going to be 0, 1. Okay, the one smack dab in the middle right here. Don't say anything. Radians. 3 pi fourths. Degrees, 135. Coordinates on the unit circle. Gosh, we got to think. We'd go left, so that's going to be negative radical 2 over 2, and we went up radical 2 over 2. So you should be able to pick any of those points on the unit circle. You should be fairly adept and quick at filling those in. Okay? So again, on this page, I'm going to make this a lot smaller so we can see the whole thing. Okay, I would know everything on there. Okay, I'm not going to ask you to reproduce everything on the test, but you can expect to see a large portion of this paper this right here on the test. And it might be worth 20 or 25% of the test, depending on how many problems I choose to put on there. So there's really no substitute for knowing these relationships, knowing these definitions. Okay? You cannot get through trigonometry without knowing that the sine is the y-coordinate over the radius, if we're talking x's, y's, and r's, or it's the opposite over the hypotenuse. Okay? And same for the other 5 trig functions. You cannot get through trig without knowing that. Okay? If I go down to the bottom here, it just says the name of these. So it says, write down the quotient identities. So the quotient identities, the one for tangent would be sine of theta over cosine of theta. Okay, please don't just write sine over cosine. Okay, remember, it doesn't mean anything without an argument. Doesn't mean anything without something plugged into those, with an angle plugged in. Okay, and then of course it's got a place for the Pythagorean identity. And then these guys right here, the cofunction identities, that's taken directly from your notes. So if you were paying attention and following along, you should have that in your notes. Okay, any questions? Sure? Okay, so everybody's clear on what the assignment is for the review. That's due on Tuesday before you take the test. Okay, so when you walk in here, you can just hand it in, and then we'll get rolling on the test. Good? Okay, I think so there's about 30-ish problems or so on the review assignment, and then this page. I think if you can do those, the test ought to be a piece of cake. Okay, I mean, literally, this is just effort and memorizing stuff. Okay, so if you're willing to work on that, then you should be in business. Okay. Okay, let's pick up where we left off. Yesterday we were talking about trig functions of any angle. That's where we came up with the definitions for sine, cosine, and tangent, and their reciprocals in terms of any point on the unit circle, x and y. If you know the x-coordinate and the y-coordinate, you can figure out what the radius would be on a big circle that would include that particular point. And we went through and we did a bunch of problems. Okay? We talked about reference angles, and I mentioned, hopefully you got that because I said it about 6 different times. I am not a huge fan of memorizing these. That's why it's not on that little study sheet that I gave you. I would much rather you understand how to find an angle on the xy plane and then think about, well, gosh, if I had 119 degrees right here, how would I figure out what's left for this reference triangle and this angle right here that's formed between the terminal side and the x-axis? Okay? Remember, a reference angle is always a positive acute angle that's formed with the terminal side and always the x-axis, never the y-axis. Okay? I suppose if you wanted to go somewhere and invent your own branch of math and your own conventions, you could do it with the y-axis. But it's done with the x-axis here. Okay? Any questions there? Okay, so let's go ahead and flip on the back page of that. And it says, reference angles are extremely useful because they allow us to use our knowledge of the trig functions for common angles in the first quadrant to figure out everything else. So as you fill out that unit circle on that study sheet, if you know quadrant 1, all you have to do is take it and kind of flip it over here across the y-axis, and you've got quadrant 2. Flip it below the x-axis, okay, and you've got quadrant 3, and then flip it back over here, and you've got quadrant 4, okay? So if you know those, then you're really in good shape. So this is going to be a good, quick review, and if you can produce this stuff, and I think I asked you to try and have this filled out, didn't I? If you can produce this really quickly, then you're already in great shape for the test. So I've labeled these in degrees. We'd want to be able to quickly turn those into radians. So this would be 0 radians. This would be pi sixths. This is going to be pi fourths. And this is going to be pi thirds. And this is pi halves. I'm not going to take the time to put each one of those on here, but we are going to think about what it would look like when we draw a reference angle or a reference triangle. For 0, this point right here is 1, 0. So the y-coordinate is the sine, and the x-coordinate is the cosine. So the tangent is the y over the x. That's going to be 0 over 1. So what's the tangent of 0? 0. Okay? Then I want 30 degrees. So I'm going to come over here, and I'm going to draw that 30-degree angle. This again would be the long leg, this would be the short leg. This is 1, this is 1/2, and this is radical 3 over 2. So again, those are the coordinates of our point. This is going to be radical 3 over 2, comma, 1/2. So this is 1/2. This is radical 3 over 2. And if you can do this without drawing a picture, then that's great. What was the tangent? What happens when we take the y-coordinate and put it over the x-coordinate? You end up with radical 3 over 3. Okay? What about right here? Got to be pretty darn quick here. Whoops, let me change back. Radical 2 over 2, radical 2 over 2. Tangent was just a 1. Okay, and if you know this one right here, what happens when we go to 60 degrees? What happens to these two coordinates? They switch places. So this is going to be radical 3 over 2. This is going to be 1/2. And if I were to, okay, this ends up being radical 3. Okay, and then if we're up here, oops, let me do this one. 1/2, radical 3 over 2. And then this would be 0, 1. So this is 1. Again, those have kind of traded places. This is 0. And what's the tangent at 90 degrees? Undefined, because we're going to take the y-coordinate, put it over the x-coordinate, so that one is undefined. Because those are defined in terms of ratios, you've got to be careful that you never divide by 0. If you do, you end up with something that's undefined. Any questions there? Okay, so let's take a look at this one right here. We want to find the sine, the cosine, and the tangent using reference angles and reference triangles. So let's think about where 300 degrees would be. 90, 180, 270, 300 degrees would be this right here. How big is the reference angle? It's only 60. We'd take 360 and we'd subtract 300, okay? Or think about it this way, it's 360 all the way around. You've used 300 of those degrees, so that makes this 60 degrees right here. That makes this the long leg, that's going to be radical 3 over 2. That makes this the short leg, 1/2, and we're on the unit circle. That's the one that we've got memorized for sure. Okay, so that would be a 1 right here. Is this correct? It's not. Okay, this is a very common mistake. Everybody gets these memorized and they're really good at spouting off 1/2, radical 3 over 2 and 1, or radical 2 over 2, radical 2 over 2 and 1 if it's a 45, 45, 90. But then they don't stop to think about, we're on the xy plane. This is the positive side of the x-axis, okay? And this is the negative side of the y-axis, so that better have a negative in front of it. So the sine of 300 degrees is negative radical 3 over 2. The cosine of 300 degrees is the positive 1/2, and the tangent of 300 degrees, we're going to take the y-coordinate over the x-coordinate, the sine over the cosine if you want to think of it that way. And what am I going to end up with? Yeah, it would be negative radical 3. I'll just show that really quickly. If I do negative radical 3 over 2 divided by 1/2, remember we're going to flip that over and multiply. Cancel these guys, okay? What was that phrase that we used to remember which ones are positive? All students take calculus. So the one that should be positive in quadrant 4 is the cosine. Lo and behold, it is. The other two are negative. Okay? What's the only other trig function that could possibly be positive in quadrant 4? Secant, the reciprocal of cosine. Very good. Okay? Any questions? Think about 3 pi fourths. Start here, there's pi halves. Remember, I like thinking of it in terms of the top half of the circle. Pi is the top half of the circle. We've got 3/4 of that, so that would make this pi fourths. That's a 1, that's a radical 2 over 2, and that's a radical 2 over 2. What common mistake do I not want to see on the test? We went left and then up. That's a negative x-coordinate and a positive y-coordinate. So the sine of 3 pi fourths, radical 2 over 2. The cosine of 3 pi fourths, negative radical 2 over 2. And the tangent of 3 pi fourths, Brandon, what is it? It's just the sine over the cosine, the y coordinate over the x coordinate. So it would be positive radical 2 over 2 over negative radical 2 over 2. So just negative 1. Okay? Make sense? Okay, again, if you know those special right triangles, all you have to do is put it in the right quadrant and attach the correct sign in front of the size of the side, the length of the side, and you're in good shape. Let's take a look at this last one. This one's a little more difficult, 11 pi fourths. 11 pi fourths. So let's stop and think about that. If you have to, think about how many times 4 goes into 11. It goes in twice with how many left over? 3/4. So that's 2 pi plus another 3 pi fourths. 2 pi would be all the way around the circle and then another 3 pi fourths right here. Why did I put an asterisk by this one? Because it's the same as this one right here. The two of these are, what's the word for the fact they end in the same place? They are coterminal. So that means that the sine of 11 pi fourths, cosine of 11 pi fourths, and the tangent of 11 pi fourths are the same as these answers we got right here. So this is going to be radical 2 over 2, negative radical 2 over 2, and this one's going to be negative 1. Again, notice that we're in quadrant 2. All students, the one with an S, the sign is the only one that's positive, and it's reciprocal cosecant. Okay, any questions there? Sure? Okay, let's take a look at the next one. This is kind of interesting, and this is the way I like to make sure that we understand this. You can actually draw a triangle for each one of these quadrantal angles, and we can figure out, so quadrantal angle just means the terminal side ends up on one of the quadrants. So if I were to take a look at this one right here, so for 0 radians, well, 0 radians technically is right here. We haven't opened up that angle at all. But if I exaggerate this by doing this, I'm going to draw a triangle with the x-axis. If this truly was 0 and that's the radius, that's always going to be positive, how big would this side right here be? If I didn't open up the angle at all, it would be 0. How big would this be? It would be 1. So you would have gone to this side, 1 unit, not gone up at all. The radius is still 1, so we can figure this out by using the opposite over the hypotenuse. That would be 0 over 1. Adjacent over hypotenuse. That would be 1 over 1. Opposite over the adjacent. That's going to be 0. With me there? Okay, at pi halves, at 90 degrees. It doesn't matter which side you swing it over to. I'm going to do this. If that truly was 90, this side right here wouldn't even exist. It would be 0. This would be the hypotenuse, and that would be the other leg right there, right? Okay, so this is exaggerated just so we can see them. Okay, opposite over hypotenuse, 1 over 1. Adjacent over hypotenuse, 0. Opposite over the adjacent. What do I get? Undefined. Okay, next one. For pi, come over here. If that truly was an angle of pi, this would be 0, this would be 1, and this would be, don't say anything out loud, I'm going to label this side right here. There's the hypotenuse or the radius. Radius is always positive. It's 1 on the unit circle. If we went all the way over here to pi, this would be a non-existent side over here. That opposite side would be 0. This is going to be a what? -1. Okay? Because you went to the left, right? Went to the left, didn't go up or down. Okay? So I'm going to do the opposite side over the hypotenuse. That's going to be 0. Adjacent side over the hypotenuse. That's going to be -1. And the opposite side over the adjacent, that's going to be 0. Okay? And the last one, I'll exaggerate it over on this side. Remember, it's tempting to draw a line over here and just make a triangle like that. It's always with the x-axis. The hypotenuse would be 1. Draw that so you can see it. Okay? This would be 0 because we wouldn't have gone right or left. The adjacent side or the x-coordinate would be 0. And what would I give to this side right here? -1. Okay? So this would be the opposite side, the y-coordinate over the radius. So that's going to be -1. That's going to be the adjacent over the hypotenuse. That's going to be 0. And then this is going to be the opposite over the adjacent. So this is going to be undefined. And what about this one right here? It's the same as the first one. So we're right back here, 0, 1, and 0. Okay? Any questions there? Okay. Just about done. Okay, it says, let theta be an angle in quadrant 3 such that the sine of theta is equal to -3/5. Find the cosine and the tangent using identities. And then it says, confirm your answer by drawing a reference triangle. So let's use identities first. If I have the sine, which of these two is probably the easiest to get? Probably the cosine. We'll use the fundamental trig identity. We'll use sine squared theta plus cosine squared theta equals 1. So in place of the sine, I'm going to put -3/5. We'll square that, plus the cosine squared of theta equals 1. This is going to be 9/25 plus cosine squared of theta equals 1. And if I want to know what cosine of theta is, I'm going to have to move this 9/25 to the other side. And then what do I need to do here to combine these? Common denominator, right? Okay, I'm going to make this 25/25 minus 9/25. What do we end up with? 16/25. Why is that a good thing? Because they're both perfect squares, right? So I end up with the cosine of theta equaling. Now, we're solving an equation and we put a plus or minus, or excuse me, a square root in a problem. So we have to have a plus or minus here. This would be 4/5. So my question for you is, how do you know which one it is? Is it the plus 4/5 or is it the minus 4/5? Minus, why? Quadrant 3. We're in quadrant 3, and the only one that's positive there is tangent, or its reciprocal cotangent. So the answer on this one is the cosine of theta is equal to -4/5. Okay, there's our answer on that one. Okay, once I know that, remember the tangent of theta is going to be the sine of theta over the cosine of theta, that quotient identity. So this is going to be -3/5 over -4/5. And lo and behold, remember we said in quadrant 3, all students take? The tangent should be positive there. And look at this, a negative over a negative is a positive. And I'm going to flip this one over. So this is going to be 3/4. So the tangent of theta is equal to 3/4. Okay. Any questions there? Okay, it says confirm the answer by drawing a reference triangle. So here's what I want you to think about on this one. They gave us the sine ratio, and they told us that it was in quadrant 3. What two sides are these? This is the opposite and the hypotenuse, or you could think of it as the y over the r, right? If the ratio there is negative, is the hypotenuse or the radius ever negative? Never. So that means the upper part of this, the numerator's got to be the negative one. So this would be -3/5. So we're in quadrant 3, and let's draw our little reference triangle. This is -3, and that's 5. Anybody recognize these sides? 3, 4, 5 triangle. You could use the Pythagorean theorem to find this one right here. If I wrote down a 4 right there, is that correct? Not correct, because we're in quadrant 3. We went back and we went down. We went back 4 and down 3. Okay? Is the cosine The adjacent side over the hypotenuse, is that negative 4/5? Yep. And is the tangent, the opposite side over the adjacent side, is that positive 3/4? Negative 3 over negative 4, we get positive 3/4. Any questions? Sure? Okay. All right. Then these last couple of problems here all revolve around the same idea, and we mentioned this yesterday. Okay, so hopefully this is relatively easy. Okay, so we want to think about what a trig function does. Okay, regular old sine or cosine or something like that. Okay, what happens is we plug in an angle, and what does it give us in return? So we always put an angle into it, and what does it tell us? We've got 18 minutes left. I can wait. What does it give us? What type of numbers? What type of answers? We get some positives and some negatives. Are they always whole numbers? No, usually they're not. Sometimes they're integers, but we get a lot of answers like radical 3/2 and 1/2 and radical 2/2 and things like that. We always get a ratio. Take a look at the definitions. If you flip on the front page, these are the definitions. You plug in an angle and it gives you a ratio of the sides in return. So that's what a trig function does. You put in the angle that you want to find out about, and it will tell you what the ratio of the sides is. Okay? So it gives you a ratio in return. But there are some problems, as we've already seen, where we already have the ratio, and we want to go backwards and we want to figure out what the angle is. So regular trig functions, we're going to write it down this way, and I'd like you to memorize this. Regular trig functions take angles and they give us ratios. Well, inverse trig function, remember, an inverse operation does the opposite. It undoes whatever the original function did. Adding 5, its inverse is subtracting 5. It undoes adding 5. Squaring undoes taking a square root. So if regular trig functions take angles and give us ratios, what do inverse trig functions do? They take ratios and they give us angles in return. Okay? So a lot of math involves finding out how to do something and then figuring out how to undo it. Okay? That's what we're talking about here. So let's think about this one right here. It says find two solutions to the equation. It does say find two. And then it says give answers in degrees and in radians. So we want degrees and radian equivalent. So let's think about this one right here. Let's think about the unit circle. If I have the cosine of an angle and I know the cosine is equal to 1/2, cosine is the x-coordinate on the unit circle. So that means this is 1/2 right here. I could label this as 1 and this is radical 3/2 and that sort of thing. But the big deal is that's 60 degrees right there, right? So one of the answers to this is 60 degrees. Is that the only place on the unit circle where the cosine ratio is equal to 1/2? If I drew the same triangle over here, the x-coordinate would be negative 1/2, right? If I drew it over here, it would still be negative 1/2. But what if I drew it right here? This is 1. This is negative radical 3/2, but do I care about that negative radical 3/2? This equation doesn't have anything to do with the opposite side. It only cares about the adjacent side and the hypotenuse, the x-coordinate and the radius. So wouldn't this work also? How big is that reference angle right there? 60, just like it was above. So how big is that angle from standard position? All the way around the circle would be 360. Subtract 60 from that, so I get 300 degrees. Okay, so the two answers are 60 and 300, or their radian equivalent, which you should be able to, at this point, do just like that. This is pi thirds, and this is 5 pi thirds, okay? You need to be able to convert that quickly. Radians to degrees, degrees to radians. We good there? Okay, let's take a look at this next one. The sine of this angle is radical 2 over 2. The y-coordinate on the unit circle is positive radical 2 over 2. Well, that would happen right here at 45 degrees. This is radical 2 over 2. Where does that happen again? Which quadrant? Well, if I did down here, this would be negative. If I did over here, that would be negative. I want a positive y-coordinate, a positive opposite side, not a negative one. So the only other place that happens is right here. If that's 45 degrees, that's 45 degrees, but what's the angle from standard position? 135. Okay? So the two answers are 45 degrees and 135 degrees, or in radians, pi fourths, again, should be that quick, and 3 pi fourths. Okay? So there are answers on that one. Any questions? Okay. Would you do this one right here? How big is that reference angle in each of these cases? 60 degrees here and 60 degrees here, okay? And again, this is why I would much rather you just memorize or figure out how this works rather than memorize some formula to figure out how to go from a reference angle to the angle in standard position. I've used 180 degrees, and for this one right here, for this first answer, all I need to do is take 180 and add 60, so that's 240 degrees. On this one, okay, I'm 60 degrees short of 360, so that's going to be 360 minus 60, so I get 300 there. Okay, those are the two answers in degrees. You can write down their radian equivalent quickly, right? Let's take a look at this one because this one's completely different. All three of the ones that we just got done doing had recognizable ratios. So if I were to do this problem right here, there are a couple different ways I can think about it. Okay, which coordinate is the cosine on the unit circle? The x-coordinate. The x-coordinate here is negative, so I could do this. This is negative 1/5. I need to find out what that angle right there is. Is there another place where I could draw a triangle that has a cosine, an x-coordinate that's negative 1/5? Quadrant? Quadrant 3. Drop that right down here. It doesn't matter that this one's positive here and that one's negative there. Makes no difference at all because we're not talking about the opposite side. The question, though, is how do I figure out what this angle is? And we did a little bit of this yesterday. Does anybody remember how to do this? We have the ratio. We want to find the angle. Grab your calculator. That's the only way to finish off a problem like this. We can take a guess at what it is. This isn't a very big side, so it should be a little bit more than 90 degrees. Okay, when you use your calculator in Trig, what are we going to do first? Check the mode. Now, I think it's a lot easier to do this in degrees to start off with. So let's check the mode. We're in degree mode. I'm going to hit second quit, and I'm going to type in theta will equal cosine inverse of negative 1/5. So let's see what the calculator gives us. Cosine inverse, negative 1 divided by 5. Does that look about right? We expected something a little bit bigger than 90 degrees. So 101.5354. 101.54 degrees. Now the big question is, what's this one? There are two ways to do it. Well, there are probably more than two ways to do it. Two reasonable ways to do it. If you know this angle right here, could you figure out what that reference angle is? By subtracting from 180. And if you know that reference angle, then you could take 180 and then you could add that angle. Or an easier way to do it would be to just go this way that many degrees. Instead of going all the way around full circle, 360 degrees, I'm going to stop shy of that by how much? 101.54. So if I took 360 and I subtracted 101.54, that would give me the other answer. So I'm going to take 360 and we're going to subtract that last answer, 258.46. And each one of those would have a radian equivalent. What do I multiply by to change from degrees to radians? Pi over 180 degrees. So I'd multiply both of those by pi over 180 degrees, and that would change it. Okay? I'd expect an answer that's a little bit bigger than 1.57 here, and I'd expect an answer that's a little bit less than 4.7 there. Okay? All right, any questions? Okay, the rest of these are just practice using that same idea. So let's take a look at this one here. This is the cosine of the angle is 0.43. In which quadrants would the cosine be positive? All students take 1 and 4. So we're expecting an answer right there. We can figure out what that first answer is by just doing cosine inverse of 0.43. So let's see what the calculator gives us there. Cosine inverse 0.43. Now, notice when you use that, it's going to give us that reference angle. In quadrant 1, that reference angle is 64.53. If that one is 64.53, how do I figure out what this one is? 360 and subtract 64.53. Okay? 360 minus that last answer. So 295. And that looks right, 295.47. Let's do this one right here. In which quadrants would we expect the sine coordinate or the sine ratio to be positive? 1 and 2, because they're both positive y's, because we were above the x-axis, the positive y coordinate there. So theta is going to be equal to, so I'm expecting an angle that's less than 90. So if I do sine inverse of 0.891, what do I get? 62.99? Is that right? How many of you are punching the buttons to confirm that? Because you're going to have to do that on your own. Okay? So that's right. If this angle right here is 62.99, that's the size of our reference angle right here. So how do I figure out what that one is? I'm not going halfway around the circle, 180 degrees. I'm stopping short of that by how much? 180 minus 62.99 would be the other answer. Okay? And that is, what is it? 117.01 or something like that. Okay. Now take a look at the instructions because this is important. For some reason, we're much more comfortable with degrees than we are radians, but notice how it wants the answer. Okay, now this little symbol right here, this means theta is an element of this. In other words, find theta that's in this little range right here, in this little integral. Okay, so if we're going to do this on the calculator, let's have this do it right. Okay, I'm going to change the mode. I'm going to come down here and change this to radian. And I'm going to type in sine inverse of 0.891. 777. Okay, do we expect it to be about there? We expect it to be less than 1.57, right? Okay, so this angle right here is 0.777 in radians. If in degrees I did 180 minus that angle, what would I do in radians? Did I do something wrong? Oh, I did. I need inverse. Okay. 0.891. That looks a little better. 1.099. Okay. So if this is 1.099 radians, how do I figure out what this angle here is in standard position? We're going to take pi and we're going to subtract 1.099. So on the calculator, we'll do pi minus that last answer there, 2.04, which is about what we expect. We expect something a little bit bigger than 1.57, so 2.04 radians. Any questions? Okay. You should be able to complete those two right there. Finish those for Monday. Monday, all I'm going to do is just take questions on 4.4 and the review and that study sheet. And I'll also, if you'll send me an email, you should get an email with basically the answers to that page. So you're studying the right thing over the weekend. Okay? All right. And we'll turn in 4.3 on Monday as well. Okay? All right. Thanks. Have a good weekend.